We are now going to show you how to make a graph on Excel. We're going to be using this for an object that's moving down an incline, and we're going to be tracking that object's velocity on the way. So we're going to get an acceleration. Our final goal is to end up with an equation that describes the motion. Now, if you look on the Excel spreadsheet in front of you, you'll notice that we have two columns. The numbers on the left column are designed to be on the x-axis of the graph, and the numbers on the right, the position, is designed to be on the y-axis of the graph. Notice the titles are very important. You'll notice they're both capitalized, and you'll notice the units, seconds and minutes, are both seconds, and meters are both next to each. Now we need to make this look more professional. One thing we need to do is to size the different cells. And you'll notice there's a trick to do a quick sizing. Watch what Mr. Hosler does to size these up. Watch the click he does. Notice he's clicking right in between the two, and it auto sizes so that all the values fit nice and neatly. Our next thing to make this truly a professional chart is to put in grid lines. We want it to print looking really pretty, and here's how that's done. And there we are. There's our chart. And notice he also decided to center all the numbers. Show us again where you did that. Yeah, see right there you can click and center everything on the chart, which is also a very professional, sharp-looking chart. Our next trick is to take those values and head toward a graph. So let's watch Mr. Hosler take us that way. He highlights the numbers. Notice not the titles, just the numbers. He's looking for a scatter plot. We just want the dots. So go to Insert a Scatter Plot, and again, choose the one with just the dots on them. And there's our graph. How pretty. The machine does it automatically, and that gives us happy feet. We're happy now that does that all for us. But notice what's missing. We don't have a title on it. We don't have an X and Y legend on it. So look where he's going. Chart layouts, the one to the left. I've learned from experience, if you don't do this now and you move on, you can't go back. So you've got to do this right now. Here we go. Click. And now he can go up and put what he wants in each one. So here we go. Remember, chart titles have to be really nice titles of what's going on, like an object rolling down an incline, perhaps, something like that. The motion of. There we go. Look at that. Isn't that pretty? And you don't put a period at the end. It's a title, even though it's written like a complete sentence. And now you go and click and do the two axes. Get the legends in there. Would be nice if there were a way to get those to automatically go in, but it just doesn't work that way. And you can kick out the series if you want. Those are really nice if you have multiple graphs on the same chart, and you'll end up leaving them, so that would be good. Now, our interest, we want the curve that best fits through those data points, and then we want the equation that describes that curve. So here's what we do. Here we go. Something fun's going to happen. Notice he clicks on one of the dots, and look at the change. And now we right-click, add trend line. And now we have a choice to make. It's kind of a guess which one's going to work best. It's definitely not linear. We can see that right away. So which of those do you think might be the best fit? My tendency with that thing would be second degree polynomial or exponential. Those would be the two I'd be thinking of. Kind of have to know the shapes to these things. Look at this down at the bottom. You can click it on so that it will display and tell you the equation that it found. There's that. And then very importantly, we need some statistical mathematical way to say how good of a fit this trend line is, and that is that R-squared correlation coefficient that we need. Oh, and there it pops right up. And that is a shocking result. Absolutely shocking. The reason it's shocking, the closer the correlation coefficient R-squared is to 1, the better fit the graph is. In this case, it's 1, which means that particular equation, y equals x squared plus 6 times 10 to the minus 14x minus 5 times 10 to the minus 13, is an exact fit for these data points. What a pretty thing. And the last thing we would want to do is change the y's and the x's, perhaps, into maybe p's and t's to make it fit the values we actually have. We want to make it look appropriate so the reader knows what we're playing around with. And there we are. We now have a distance-time equation that fits the motion of that object rolling down the incline. How cool is that?